Hello, everybody. You will want to pull out your Notes 2.1 template. If you did not get a copy of this template, then you will want to look on your Google Classroom, and there should be a copy there for you to either make a copy of or somehow print out, but you will want to take notes as we go along. There's going to be a lot of stuff we talk about today. So we're going to start out by talking about our universe. Our universe is comprised of three main things. We have the space, which is kind of nothingness where there is no mass and no energy. Then we also have matter. Matter is anything that has mass and takes up space. This is usually, we call it kind of stuff. Okay. It's really, really hard to think of things that are considered not matter, but is really easy to come up with a long list of things that are considered matter. Then we also have energy. Different types of energy. We talked about energy very, very briefly earlier in the week. And some different types are your heat, light, sound, and motion. So let's get started. We're going to talk about atoms. Atoms is the smallest particle of an element that retains the chemical identity of the element. So atoms of different elements have different number of protons. That's how we can tell what something is. If it has 2 protons, it is one element. If it has 3 protons, it is a completely different element. So a molecule is when we have 2 or more atoms joined together by a chemical bond. So if we take a look at H2O, you'll notice that there are 2 hydrogens there and 1 oxygen. Because we have 2 or more atoms chemically bonded together, that is usually what we refer to as a molecule. So as I stated before, matter is anything that has mass and takes up space. If you don't have those 2 things, then it is not considered to be matter. We then talk about mass, and you have to be careful because mass and weight are 2 different things. Right now we're going to talk about mass. Mass is the quantity or the amount of matter in an object. The way that we measure mass, the units, is actually in grams. Volume is the space that object takes up. So as you can see by our definition for matter, anything that has mass and takes up space, it must have mass, but it also must have some sort of volume attached to it as well. Volume can actually be measured 3 different ways, and you're going to get some practice in doing this not only online, but also in lab. We can measure it directly. We can do volume displacement, or we can measure it and calculate it using length times width times height. So if we take a look at volume again, okay, volume, remember, is how much space the matter takes up. So when we look at these, we can do it 2 different ways in terms of measuring. Our irregular objects, by irregular objects, they're not really like cubes or anything like that. We would do that like a rock would be an irregular object. We calculate the volume of these using water displacement. That is when you put it in a graduated cylinder or some sort of water and you figure out the amount of volume that that object actually makes the water go up. My regular objects, we just use my measurements. That's where we can do length times width times height. So all matter can be classified into 2 main categories. We have pure substances and we have mixtures. And as you can see, this flow chart, you will be able to use this flow chart and help you identify whether something's then eventually an element, a compound, a homogeneous mixture, or a heterogeneous mixture. So pure substance. A pure substance cannot be separated by physical means. What I mean by physical means is I can actually separate it almost with my hands. Okay? So pure substance are either elements or compounds. Some examples of elements there are magnesium, copper, silver, gold, anything on the periodic table of elements. Elements are atoms that cannot be divided further and still possess the same properties of that element. So when I have an potassium, I cannot break that down any further. If I do, that means that it's not potassium anymore and it's something else. Compounds, remember, compounds is when we combine two or more elements combined in a fixed ratio, meaning H2O, you will always have a 2-to-1 ratio in that case. We then have my mixtures. Mixtures are when you combine two or more pure substances. So notice how I say pure substances, because you can have either two elements combined together or even two compounds combined together, or one of each. Now, the key thing is these can be separated by physical means. Okay, so some examples of mixtures is Pepsi, coffee, fruit salad, ice cream, things like that. Okay. We then can go a little bit further. There's two types of mixtures that we can talk about. Homogeneous mixture is any sample that has the same composition throughout, meaning I cannot see the different parts in that mixture. So if I take salt water, I cannot tell the difference between the salt and the water in there. And every single kind of sample that I take out of that saltwater beaker, it's going to have the same composition, meaning I'm going to have the same percentage of salt and water. And notice how I say same percentage, because the percentage does not have to be 50-50. Okay, if I take a look at my cup of coffee, if I think about my coffee and I throw some creamer in there, I don't put 50% coffee and 50% creamer. I maybe do a 20-80. Okay, so every sip that I take, I am getting a 20-80 percentage. My heterogeneous mixtures, these heterogeneous mixtures, I have different compositions, meaning every sample that I take, it's gonna be a different ratio. The best example would be my fruit salad. Every scoop that I take, I'm not gonna get the same amount of grapes in that one.